So this is 6-5, solve exponential equations. These are called exponential equations because the variable you want to find, to solve for, x, basically, x is in the exponent, and that makes it an exponential equation. And we'll get some modeling, like Newton's cooling law, is coming in this section, uses an exponent. You have to solve an exponential equation because things cool on a exponentially. So what you do is you have to get each side. The easiest way to solve these, if you can, the fastest, easiest way is to get the bases to match. And then you just set the exponents equal to each other. So let's see how that works in number one. We have the bases are 9 and 27. What's in common? What is the common base? In other words, what number can you write to a power that will give you both 9 and 27? What's the lowest? 3. There you go. Okay, very good. So we just take 9 is 3 squared, and 27 is 3 cubed. Everyone agree? Okay, and then we still have a 2x here, and we still have an x minus 1 here. Very important that you have parentheses. That was the hardest step. Now, you can think of like canceling the 3's, or just match up the exponents. So we don't need these anymore. So you can just say 2 times 2x equals 3 times x minus 1, and we have a basic, what kind of equation is this? It's out, yeah, they're all algebraic. What function family? This is quadratic. Really? Linear, thank you. Okay, subtract 3x from each side. And you get x equals -3. Okay, so here we go again. So questions on that one? Okay, number 2. Our bases are 3 and 1/9. This is slightly trickier, but what's the common base, do you think? The lowest? It's just going to be, let's keep it simple. It's just going to be 3. Okay? So this we can leave alone, but we have to write 1/9 differently. So I'll do it one step at a time. Let's start with 1 over 3 squared. And this is still raised to the x plus 3 power. Okay, and now 3, so how can I just make it 3? What happens to the exponent if I move it up? Yeah, it becomes -2. And it's still to the x plus 3 power. So I just changed 1 over 3 squared is the same as 3 to the -2 power because of the laws of exponents. And now I can just set the exponents equal. So I have x equals -2 times x plus 3. And now we're good to go. Now we're back to like unit 1 in algebra 1. -2x, we'd use the distributive property, add 2x to each side, divide by 3. And that's solved. Okay, so in this one, 10, 100, and 1,000, what's the common base? 10, good. So that's 10 squared. And this is 10 to the 3rd, good. And again, we just ignore the 10s now and set the exponents equal to each other. So you get 2 times 7x plus 1 equals 3 times 3x minus 2, or 14x plus 2 equals 9x minus 6. Subtract the 9x from each side. Subtract 2 from each side. And you get a fraction, and that's fine. -8/5. Definitely don't want to do guess and check to try to find that answer. Okay, so any questions on if you can get a common base, then that's what you do. But unfortunately, not every equation just works out where you can get a common base, like the things that we've been doing already. So this will look like review to you. So if you can't get the same base, you have to take the log or the natural log of each side. If you can't, how do you know which one? If you ever have an e, then you take natural log because those are inverses. Good question. Okay, so here a 2 and a 5. There's just no way you're going to get them to be 2 to the same power. So you take the log of each side. This is total review. Log of each side. And then the power rule lets you bring this exponent down. And then you divide both sides by log 2. So log 5 over log 2. And if you just do that carefully on your calculator, you'll get about 2.32. Okay, now this looks like really crazy. 4e, which is just a number, raised to the negative 0.3x power. But real science equations do end up being this messy. Minus 7 equals 13. So you should hopefully you remember that you just unwrap. It's like a present that you're unwrapping. You just get rid of the layers on the outside. So the number that what number can you get rid of first?
+7.
Yes. So don't think it's some strange new frontier that you're on. You just make it simpler for yourself before you even get started. Make everything easy. What else do we get?
4.
Yeah, divide by 4. Mm-hmm. So we have e raised to the negative 0.3x equals 5. And this is not a problem because what do we just do? We're not going to get them the same base. So what do we do to each side? Yeah, so then you take ln, natural log of each side. Okay, and now remember the expressions we simplified the other day? What happens when you have natural log and then e raised to a power? They cancel out, that's right. So this cancels out and you get negative 0.3x. Does anything cancel out here? No, it's just natural log of 5, and there's a button on your calculator that will get that number for you. And then you simply divide by negative 0.3, which is also a constant. And so that's very doable on your calculator. You take the natural log of 5, be sure you hit enter, and then divide by negative 0.3, and you'll get negative 5.36 for that. And the last one, so should we use natural log or log? Log. So we get log 7 to the 9x equals log 15. And then you just bring this whole power down to the front. So you get 9x log 7 equals log 15. And then you just divide by 9 log 7. Divide by 9 log 7, which is all just a constant. So you'll get about 0.155 for that one.